Okay, here we go. Net change theorem says as follows. The integral from a to b of f prime t dt is equal to f of b minus f of a. Looks pretty similar to what we've talked about regarding the fundamental theorem of calculus part 2. Find an antiderivative, plug in a and b, and we're good to go. The difference is in terms of its application. So the example I'm going to give to you is that this is a rate function here, a rate function. So the example is the integral of a velocity function will give us displacement. The integral of a velocity function will give us displacement. So if you recall, we have s of t, that's position. We have v of t, that's velocity. A of t, that's acceleration. And j of t, that was jerk. Yeah, exactly. Just kick a guy when he's down. It's like, it's all right. So we talked earlier in this year about the position function. What did we do the position function in order to get the velocity function? And then we took a second derivative in order to get acceleration, correct? Well, the deal is, suppose we get a velocity function, we integrate it. Well, first you'll take the antiderivative, which will provide the position. And when you plug it in a and b, that will then give you the displacement. And so when you're given a rate function, it's very helpful to use the integral. And we'll show you one example today, and tomorrow we'll get much more in depth. I will say that the use of this is a crucial part to the AP exam. We're going to look at this many times over the course of the rest of the year. I will say that the first part of your test, which is finding antiderivatives, which you guys were working on last week, you know, overall that goes pretty good. I would say that these type of questions seem to be a definite struggle for students. So your ability to focus and lean in during this time is going to be crucial. A lot of people like to try to just pick up the pieces at the end right before the test. Really doesn't seem to work very well for this section, because I don't ask the questions exactly the same way on the test, because I want you to show that you truly understand them. Like, for example, have you guys ever gotten to a test in any class where, like, there's a question, it's part A, B, C, D, and E, and you realize at the end of the day, you're like, oh, what do you do for part A, part B, part C, and part D? You're just memorizing what you're supposed to do. But suppose you switch around the context for A, B, C, and D. You know what I mean? Suppose I ask question A, but I put it in question B. You actually have to know what you're doing. You can't just memorize an algorithm or a process. We got to see you actually know what you're doing. And a lot of people don't take the time to do that. You might actually have to come in for help during this unit. That might be required of your part. So, or just take a C or a D. So, all right, here we go. So, suppose we say that the integral from a to b of f of x dx, f prime of x dx, of v of t dt is equal to displacement. We'll pick up with there when we get back. All right, here we go, guys. Let's pick it up, okay? If you take the integral of the velocity function, you get displacement. But when I asked you guys the total distance I traveled, Brody said it was 15 feet from here to the door, right? B wrote. So what was the total distance I traveled? 30. Yeah, you took the absolute value of each. So the absolute value of the velocity function, when you take the integral of that, that's where we get distance. So if we just do the integral of the velocity function, we get displacement. If we do the integral of the absolute value of the velocity function, we get total distance traveled. And we're going to do these first two by hand. Tomorrow I'm going to show you how to do it using a calculator. Okay. So particle moves at a velocity modeled by the function v of t is equal to that guy, where t is measured in seconds and v is measured in meters per second. Okay, it says find the net change or the displacement. So net change and displacement are really synonymous over the interval 1 to 4. First of all, what I want to do is I want to look at the function of velocity. T squared minus t minus 6. What shape does that make? I've got t minus 3 and I've got t plus 2. So that means it crosses the x-axis at negative 2 and at positive 1, 2, 3. And so this is what I get. Okay. Now, I'm trying to find the area from 1 to 4, and that will give me the overall displacement. What do you notice about that area? Positive and negative. So the negative represents the amount or the distance that it will travel in the left direction, and then the positive area represents the distance traveled in the right direction. Do you think the overall displacement will be positive or negative? Why? And it's more negative area. So just to be clear, okay, if I consider this spot right here on the graph, am I traveling in the left direction or the right direction? Right. Now, no, not right. In the left, because this is the velocity function, right? So is the velocity positive or negative here? It's negative. Okay. So if I gave you the position function, then you would look at the derivative. You'd say, oh, the derivative is positive. It's increasing, so therefore I'm traveling in the positive direction. But this is the velocity function. So is the velocity positive or negative? It's negative because it sits below the x-axis. Therefore, it's traveling to the left, and that's why we have negative area being collected at that time. All good? Okay, let's evaluate this integral by hand. Find the net change or the displacement. We're going to look at the integral 1 to 4 of t squared minus t minus 6 dt. Antiderivative of t squared minus t minus 6. T cubed over 3. And you evaluate that. 1 and 4. About 65% of the AP exam, you're not allowed to use the calculator. About 35% you are. We're going to try without the calculator right now. Okay. 64 over 3 minus 8 minus. Now I'm going to plug in 1. 1/3 minus a half minus 6. 64/3 minus 1/3 is 63/3, which is, I've got 21 out of that. Got negative 8 and negative 24 is negative 32 minus a negative 6. So I have to add the 6. Is it a positive 1/2 or a negative 1/2? So 21 minus 26 is negative 5 plus 1/2, negative 4.5. And you guys said it would be negative overall displacement because you saw that the area below the x-axis was there was more negative area than it was positive area. Let's check this out, see what we get. Okay. Yes. Second calculate, number 7. 1, 4, negative 4.5. Okay. Now, we need a label here. What is our distance? Meters per second, so therefore it would be negative 4.5 meters. Y'all good? Okay, so this is the second piece that we're going to do. Now we're going to do B. B says that we want to find the total distance. We need to find the absolute value then of the function over that time. Now, I want to show you what that looks like graphically so you can appreciate that this is going to be a little bit more challenging. If I take the absolute value, that means everything becomes positive, correct? So that's the graph of the absolute value of v of t. And the part that sits below the x-axis comes to the top. So what we want to do is we want to find this negative area here, and we want to make it positive, and then add that to the positive area. Exactly. We found where it changes from positive to negative, which is going to be 3. And we'll break it into 2 parts. We're going to find the area from 1 to 3 of t squared minus t minus 6 dt. And we're going to add that to the area from 3 to 4, t squared minus t minus 6 dt. Which one of these areas is negative, the first one or the second one? So therefore, we will take the absolute value of the result. And that will tell us then the total distance traveled when we add them together. So here we go. T cubed over 3 minus t squared over 2 minus 6t evaluated 1 and 3. Plug in 3 and you get 9 minus 9 halves, 18. Minus, now I plug in 1. I get 1/3. I like to combine, kind of whole numbers and then fractions. So got 9 minus 18 is negative 9. Negative 9 minus a negative 6. Negative 3. Negative 9 halves minus a negative 1 half. Minus 4. Positive 1/3 or negative 1/3? So negative 3 minus 4 is negative 7. So I get negative 7 1/3, right? Or if I convert that to an improper fraction, I got negative 22 over 3. But it says that I want the absolute value. So I've traveled 22/3 in the opposite direction. So 22 over 3. And I'm going to add that to, now I need to come up with the area from 3 to 4. Will the area from 3 to 4 be positive or negative? Positive. So we do the same thing. T cubed over 3. T squared over 2. Minus 6t. Evaluated. Over 3 minus 8 is 24. I plug in 3. Okay. I'll look at my whole numbers first. I've got negative 8, negative 24 make negative 32. Minus 9 is a negative 41. Plus 18 is going to be a negative 23. plus 64 thirds plus 9 halves. What would the common denominator be? 6. 6 times 23. Let's see, 6 times 20 is 120. 6 times 3 is 18. So negative 138 over 6 plus, I'll multiply top and bottom here by 2. I get 128 over 6. 27 over 6. 17 over 6. So travels 22 over 3 meters in the negative direction. Travels 17 over 6 meters in the positive direction. Common denominator of 6, so I got 44 over 6 plus 17 over 6 is 61 over 6 meters, which is exactly 10.16 repeating. And I'm going to show you how to verify this on your calculator. Although I show people how to do this, I know, again, people sometimes don't tune in until the right time. I had a bunch of your fellow students who, and a lot of people did not check their answer last year. Some people didn't even know how to plug this in. They're like, Mr. Getz, I didn't even know how to do that when I got to my calculator. That's the measure of you as a math student then. So what I do is I simply put an absolute value around that piece. And now look at the graph. And so I'm going to calculate number 7. And my lower limit is 1. My upper limit is 4. And it does exactly what we wanted it to. Does it come up with the correct answer, though? It's an approximation. Your calculator can't do the exact value. It does an approximation. Might make, say, 1,000 rectangles. Okay? Whereas, we do an infinite number of rectangles. So we're smarter than the calculator here, okay? Yeah. No, you cannot. You can't do anything with this to determine the final result. The fact that its overall displacement is negative 4.5, we can't use that to come up with the 10 and 1/6. The important part, B Road, is that you consider this 3 spot right here. That's you have to consider 3. And in your first one, when you did displacement, you didn't have to use the 3, did you? But the second one you did, and that's critical. Okay. So I'm going to give you guys your